Concept of chemistry. Chemistry is the science of molecules and their transformations. It is the science not so much of the 100 elements but of the infinite variety of molecules that may be built from them. Roald Hoffman. Science can be viewed as a continuing human effort to systematize knowledge for describing and understanding nature. You have learned in your previous classes that we come across diverse substances present in nature and change in them in daily life. Curd formation from milk, formation of vinegar from sugarcane juice on keeping for prolonged time and rusting of iron are some of the example of changes which we come across many times. For the sake of convenience, science is subdivided into various disciplines: chemistry, physics, biology, geology, etc. The branch of science that studies the preparation, properties, structure, and reactions of material substance is called chemistry. Development of chemistry. Chemistry, as we understand it today, is not a very old discipline. Chemistry was not studied for its own sake, rather, it came up as a result of search for two interesting things. First, philosopher stone called paras, and which would convert all baser metals, example iron and copper, into gold. Second, elixir of life, which would grant immortality. People in ancient India already had the knowledge of many scientific phenomena much before the advent of modern science. They applied that knowledge in various walks of life. Chemistry developed mainly in the form of alchemy and electrochemistry during 1300 to 1600 CE. Modern chemistry took shape in the 18th century Europe after a few centuries of alchemical traditions which were introduced in Europe by the Arabs. Other cultures, especially the Chinese and the Indian, had their own alchemical traditions. These included much knowledge of chemical processes and techniques. In ancient India, chemistry was called Rasayan Shastra, Ras Tantra, Ras Kriya, or Ras Vidya. It included metallurgy, medicine, manufacture of cosmetic, glass, dyes, etc. Systematic excavation at Mohenjo-daro in Sindh and Harappa in Punjab prove that the story of development of chemistry in India is very old. Archaeological findings show that baked bricks were used in construction work. It shows the mass production of pottery, which can be regarded as the earliest chemical process in which material were mixed, molded, and subjected to heat by using fire to achieve desirable qualities. Remains of glazed pottery have been found in Mohenjo-daro. Gypsum cement has been used in construction work. It contains lime, sand, and traces of CaCO3. Harappans made fans, a sort of glass which was used in ornaments. They melted and forged a variety of objects from metals such as lead, silver, gold, and copper. They improved the hardness of copper for making artifacts by using tin and arsenic. A number of glass objects were found in Musky in South India 1000 to 900 BCE and Hastinapur and Takshila in North India 1000 to 200 BCE. Glass and glazes were colored by addition of coloring agents like metal oxide. Copper metallurgy in India dates back to the beginning of Chalcolithic cultures in the subcontinent. There are much archaeological evidence to support the view that technologies for extraction of copper and iron were developed indigenously. According to Rig Veda, tanning of leather and dyeing of cotton were practiced during 1000 to 400 BCE. The golden gloss of the black polished where of northern India could not be replicated and is still a chemical mystery. These wares indicates the mastery with which clean temperature could be controlled. Kautilya's Arthashastra described the production of salt from sea. A vast number of statements and material described in the ancient Vedic literature can be shown to agree with modern scientific finding. Copper utensils, iron, gold, silver, ornaments, and terracotta discs and painted clay pottery have been found in many archaeological sites in North India. Sushastra Samhita explained the importance of alkalis. The Chadak Samhita mentioned ancient Indians who knew how to prepare sulfuric acid, nitric acid, and oxide of copper, tin, and zinc. The sulfates of copper, zinc, and iron, and the carbonates of lead and iron. Rasopanishada describe the preparation of gunpowder mixture. Tamil texts also describe the preparation of fireworks using sulfur, charcoal, saltpetre, that is potassium nitrate, mercury, camphor, etc. Nagarjuna was a great Indian scientist. He was a reputed chemist and an alchemist and a metallurgist. He worked Ras Ratnakar deals with the formulation of mercury compound. He has he has also discussed method for the extraction of metals like gold, silver, tin, and copper. A book, Ras Arnava, appeared around 800 CE. It discusses the uses of various furnaces, ovens, and crucibles for different purposes. It describes method by which metals could be identified by flame color. Chakrapani discovered mercury sulfide. The credit for inventing soap also goes to him. He used mustard oil and some alkalis as ingredients for making soap. Indians began making soap in the 18th century CE. Oil of iranda and sheets of mahua plants and calcium carbonate were used to making soap were used for making soap. The painting found on the walks of Ajanta and Ellora, which look fresh even after age, testify to a high level of science achieved in ancient India. Varamahir's Briham Samhita is a sort of encyclopedia which was composed in the 6th century CE. It informs about the preparation of glutinous material to be applied on walls and roofs of houses and temples. It was prepared entirely from extracts of various plants, fruits, seeds, and barks, which were concentrated by boiling and then treated with various resins. It will interesting to test such materials scientifically and assess them for use. A number of classical texts like Arthaveda 1000 BCE mention some dye stuff, the material used for turmeric madder, sunflower or piment, cochineal and lac. Some other substance having tinting property were Kamplesika, Patanga and Jatuka. Vadamahir's Braham Samhita gives reference to perfume and cosmetic. Recipe for hair dyeing were made from plants like indigo and minerals like iron power, black iron or steel and acidic extract of sour rice gruel. Gandha Yukli describe recipe for making scent, mouth perfumes, bath powders, incense, and talcum powder. Paper was known to India in the 17th century as account of Chinese traveler. Artistic, Artisting describes excavation at Taxila indicate that ink was used in India from the 4th century. Colors of ink were made from chalk, red lead, and minimum. It seems that the process of fermentation was well known to Indians. Vedas and Kautilya's Arthashastra mention about many types of liquids. Charak Samhita also mention ingredients such as barks of plants, barks of plants, stem, flowers, leaves, woods, cereals, fruits, and sugarcane for making asavasas. The concept that matter is ultimately made of indivisible building blocks appeared in India a few centuries BCE as a part of philosophical speculation. Acharya Kanda, born in 600 BCE, originally known by the name Kashyap, was the first proponent of the atomic theory. He formulated the theory of very small indivisible particles, which he named Parmanu comparable to atoms. He authored the text Sutras. According to him, all substance are aggregated form of smaller units called atom, that is Parmanu, which are eternal, indestructible, spherical, supersensible, and in motion in the original state. He explained that this indivisible entity cannot be sensed through any human's organ. Kanda added that there are varieties of atoms that are as different as the different classes of substances. He said these Parmanu could form pairs of triplets, among other combinations, and unseen force cause interaction between them. He conceptualized this theory around 2500 years before John Dalton, 1766 to 1844. Charak Samhita is the oldest Ayurvedic epic of India. It describes the treatment of diseases. The concept of reduction of particle size of metals is clearly discussed in Charak Samhita. Extreme reduction of particle size is now termed as nanotechnology. Charak Samhita describes the use of bhasma of metals in the treatment of elements. Nowadays, it has been proved that bhasma have nanoparticles of metals. After the decline of alchemy, electrochemistry reached a steady state, but it too declined due to the introduction and practices of Western medical system in the 20th century. During this period of stagnation, pharmaceutical industry based on Ayurveda continues to exist, but it too declined gradually. It took about 100 to 150 years for Indians to learn and adopt new techniques. During this time, foreign product poured it in. As a result, indigenous traditional techniques gradually declined. Modern science appeared in India, seen in the latter part of the 19th century. By the mid 19th century, European scientists started coming to India and modern chemistry started growing. From the above discussion, you have learned that chemistry deals with the composition, structure, properties, and interaction of matter and is of much use to human beings in daily life. These aspects can be best described and more understood in terms of basic constituent of matter that are atoms and molecules. That is why chemistry is also called the science of atoms and molecules. Can we see, weigh, and perceive these entities, atoms and molecules? Is it possible to count the number of atoms and molecules in a given mass of matter and have a quantitative relationship between the mass and the number of these particles? We will get the answer of some of these questions in this unit. We will further describe how physical properties of matter can be quantitatively described using numerical values with suitable units. Then 1.1 importance of chemistry को हम next live video में cover करेंगे. हरे कृष्णा, thank you.